Hi, my name is Kate Hoffbauer, and I'm a second-year biology major from the class of 2020.
Hi, my name's Kayla Kowaleski, and I'm a second-year kinesiology major, also from the class of 2020.
Today we'll be working through Problem 7 from the Skill Builder Chapter 4.5 Practice Problems. Before we begin working out this problem, we recommend that you try to work out this problem on your own first to see if you get the right answer. Please pause the video now until you have completed the problem or have reached a point where you need our help. Then we will go over it together.
This question states the combustion analysis of a 5.024 milligram sample of conine, which is a toxic substance isolated from hemlock that contains only carbon, nitrogen, and hydrogen, yields 13.93 milligrams of carbon dioxide and 6.035 milligrams of H2O. Part A of this problem asks what the percent composition by mass of conine is. Step 1 is to find the grams of carbon by itself from the mass of carbon dioxide, and we can do this because this is the only place where carbon appears in the products. We can perform this conversion using dimensional analysis. Knowing the molar mass of carbon dioxide is 44.01 grams, we can find the moles of carbon dioxide from the 13.93 milligrams of carbon dioxide. From the moles of carbon dioxide, we can now find the moles of carbon within that compound using the molar mass of carbon. We now know that there are 3.79 milligrams of carbon in this sample of conine. Given the total mass of conine is 5.02 milligrams, we find the percent composition of carbon within the compound to be 75.4%. Step 2 is to repeat the same process with hydrogen by finding the grams of hydrogen itself from the mass of H2O, because that is the only place where hydrogen is present in the products. We can perform this conversion using dimensional analysis as well. Knowing the molar mass of H2O is 18.02 grams, we can find the moles of H2O from the 6.053 milligrams of H2O. From the moles of H2O, we can find the moles of hydrogen within the compound using the molar mass of hydrogen. We use 2.02 grams rather than 1.01 grams because there are two hydrogens in H2O's formula. We now know that there are 0.679 milligrams of hydrogen in the sample of conine. Given the total mass of conine in this sample is 5.02 milligrams, we can find the percent composition of hydrogen in this sample to be 13.5%. Because the question states that conine only contains carbon, hydrogen, and nitrogen, we know that the percentage left over belongs to nitrogen, which is 11.1%.
Part B of this problem asks what the empirical formula of conine is. Using the percent composition of carbon, hydrogen, and nitrogen, we can compare their percentages to each other in regards to grams by assuming a total sample of 100 grams of conine for proportion purposes. We can convert the grams of each element to its moles using its molar mass to compare across all three. Now that we have the moles of carbon, hydrogen, and nitrogen, we can find the ratio of each in terms of whole numbers by dividing all three elements by the moles of nitrogen because it has the least amount of moles. We can see that when we do this, we find the empirical formula to be C8H17N.
In the last part of this problem, part C, we are told that the molar mass of the sample is equal to 127 grams per mole, and we are asked to determine the molecular formula of conine. While the empirical formula gives us the least common multiple of a particular formula, molecular formula gives us the actual ratios of the elements in the compound. To determine the molecular formula for conine, we will divide the given molar mass by the molar mass calculated of our empirical formula. This calculation gives us a value of 1, therefore our molecular formula is also equal to C8H17N. If this number had been greater than 1, for example, if we have calculated 2, we would multiply the subscripts of the empirical formula by 2 to get the molecular formula instead.
Thank you for watching our video. We hope this explanation was helpful.